Hello students, today we are going to study basics and energy of the atmosphere. If you are a school going student, I'm sure you have already studied about the basics of the atmosphere with so many distinctive features. But to go into little details, it is not just a column of air, it is much more than that. It is a combination of different mixtures, different features, which helps in the existence of life, which helps in the present situations of the climate, of the oceans, of whatever is happening around us. It protects us from the sun. It acts as an insulator. It provides air to us, which is the most important requirement for our survival, and it controls the atmospheric temperature, the temperature without which we might have been baked on this planet. So it is not just a air blanket or not just an air column which is surrounding us. So atmosphere provides us with so many indescribable features who which sorry protects us, which provides us with the life giving conditions on this planet. But the air that comprises this atmosphere is not just a single type of gas. The atmosphere is a combination of different types of gases which combinedly form the atmosphere. Being a mixture of so many types of gases is a unique combination that only Earth is bestowed with. This unique combination provides us with different types of gases, some of which are life giving, some of which are useful for the plants, some of which are helpful in maintaining the temperature of the atmosphere, and so on. So, the atmosphere is a combination of different types of gases. We don't see the gases, of course, they are in gaseous form, they are odorless, they are colorless, they are tasteless, but nevertheless, they do have their specific features. Some gases are lighter, some gases are heavier, some gases uh, uh, are found close to the surface, some gases are found above the air column, above the tropospheric layer. So we see that these distinct features of different gases create the atmosphere. To move on to the composition of the atmosphere, the combination of different types of gases is mentioned in this table below. You can see that the maximum part is included of nitrogen comprises around 78.1% of the atmosphere. The next in line is oxygen, that is around 20.95%. Then argon, that is about 0.93%. Carbon dioxide is around 0.03%, and others would include gases like neon, ozone, water vapor, hydrogen, helium, methane, nitrous oxide, etc. So, this combination forms the atmosphere. The next is atmospheric pressure. Atmospheric pressure is nothing but the column of air which is surrounding the earth. The air posing weight on the atmosphere is called the atmospheric pressure. As you can see that the distance of the atmospheric layer from near the poles is less in comparison to near the equator. There is a reason for this. The reason is that near the poles the temperature is usually very low. This forces the air around the area to contract and to accumulate in a limited or a small zone. This pulls the air column down. Thus, we get to this condition. On the other hand, in the areas near the equator, the temperature is comparatively high because this area receives the maximum sun rays in comparison to the polar zones. This leads to increase in temperature, thus expanding the air column in the respective zone. So, the atmospheric pressure is the weight that this air column puts on the surface of the earth. This weight is denoted with millibars. And to come to the specific data, we have the atmospheric pressure at the sea level of around 1013.25 millibars or 1033.3 gram per square centimeter, and the average pressure over the earth's surface starts reducing as we go higher in altitude. You can see in these diagrams that the air molecules are closer or are rather heavier in this close to the surface zone. The reason is that here we are in the troposphere layer, and with uh, the air weight that is being put on the surface, we also have the gravitational pull. The gravitation which pulls the air column close to the surface. So we find that the maximum accumulation of gases is close to the surface, and as we go higher, the force of the gravitation starts reducing. You can see it in the next diagram that it is the gravitational force, which is pulling the gas down, and the air column of 1 meter square contains the mass of 10 to the power 4 kilograms of gas or atmosphere. The total weight of the atmosphere is around 5.9 into 10 to the power 5 tons. But the properties typical of a gas really cease to exist at around 600 kilometers in altitude. So we see that the atmosphere is not just any column of air, it is comprised of different kind of gases. It has weight, and this atmospheric pressure is also important because when we study this in geography or in physics as well, the atmospheric pressure is the counter force that is acting against the gravitational pull, and if it were not there, we might have you know to exaggerate or to see it in a funny manner. The gravitational pull could have been so strong that it would pull us inside. It is the atmospheric pressure, which is the opposite force against the gravitation, and this balance is then again a unique feature of the atmosphere. In the next lecture, we'll start with the atmospheric layers.